Special triangles. Here you have two triangles that are listed. The special triangles are 45, 45, 90 and 30, 60, 90. Note that for the 45, 45, 90, two of the sides are equal, and that should go with the fact that there are two angles that are equal. The smallest sides, we call them 1, and if you use the Pythagorean theorem, you'll learn that the hypotenuse is 1 times the square root of 2. That's essentially how it works. I mean, if the smallest side were, say, 6, then this would be 6 root 2. You would multiply by root 2. This were 8, then 8 root 2. On the other hand, if the largest side here were 8, then you would divide by root 2. So it would be 8 divided by root 2. In any case, we're simply calling it 1 because we're going to be using trigonometry. And with trigonometry, it's all about ratios and fractions, and these fractions are going to end up reducing. So if this were 8, and that's 8 root 2, the 8s would essentially go away. Over here for the 30, 60, 90 triangle, I want you to note that the 30-degree angle is the smallest angle. If you draw an arrow out, you will locate the smallest side. Angles and sides do have a relationship in geometry. You may recall that the largest angle, 90 degrees, opposite is the largest side. The medium angle, opposite medium side. Smallest angle, opposite smallest side. And that's something you want to be cognizant of, especially if you have to do any kind of testing. Sometimes in tests, pictures will be drawn so that they do not look like one side does not look smaller than the other. So you'll want to know where those numbers go. I also want to note that 2 is larger than the square root of 3. 2 is the largest side. And a lot of times people make the mental mistake in thinking that root 3 is smaller, but keep in mind the square root of 3 is smaller than the square root of 4. And if you understand that little fact, then you should also recognize what the square root of 4 is equal to. Let's do one problem here. Let's determine the sine of 60 degrees, and you'll note that the direction says exact value, which basically means calculator answer is probably not going to work, nor will a table work here. When you see exact value, you're basically being told to use a special triangle. 60 degrees is over here, so that's this particular triangle, so why don't we just focus on it. Let's identify the sides with respect to the 60-degree angle. In other words, which side is the hypotenuse? The 2 is. You'll note that the right angle is always pointing at the hypotenuse, the largest side. To determine the opposite side, take your angle in question here and draw an arrow out from it. And you'll determine the opposite side every time. This leaves the third side as the adjacent side. Recall that the word adjacent means next to, so what we're essentially looking for is the side that is next to the angle that isn't already the hypotenuse. Okay, it's the sine that we want. Recall the sine is the opposite over the hypotenuse, and I think many people use this to help remember these ratios, SOHCAHTOA. According to this, the sine is the opposite over the hypotenuse. So therefore, the opposite side, root 3, the hypotenuse, 2, that's our answer. How about this one? Determine the secant of 45 degrees. The 45, 45, 90 triangle is what we need to focus on. We have two 45-degree angles here, so let's just pick one. I'll choose this. And again, just as before, determine all the different sides. Square root of 2 is the hypotenuse. And drawing an arrow out from 45 degrees, we get the opposite side. That leaves the adjacent side down below. Now the secant, you'll recall, is the reciprocal of cosine, which basically means we need to determine the cosine first. Well, the cosine is the adjacent over the hypotenuse. Since the adjacent side is 1 and the hypotenuse is root 2, that's what we get. And that would be the answer if we were looking for the cosine. But again, it's the secant that we want. Since the secant is the reciprocal, we're just simply going to take this answer here, and we're going to flip-flop the numbers. Thus, the square root of 2 is our answer. Let's do one more. The tangent of 30 degrees. Again, we're going to have to refer to this particular triangle because of the 30-degree angle. We'll want to identify our sides again. Drawing an arrow out here, we get the opposite side. The right angle opposite is the hypotenuse. Therefore, that leaves us with the adjacent as root 3. So as you can see, the adjacent side isn't always on the bottom. Now, the tangent, you'll recall, is the opposite over the adjacent. The opposite side is 1, hypotenuse is 2. Sorry, the hypotenuse is 2, but we don't need that. The opposite side's 1, the adjacent side's the square root of 3. So 1 over root 3 would be it, except we typically do not finish with a radical down here in the denominator. So what we're going to need to do is we're going to need to rationalize that denominator. Let's go ahead and multiply top and bottom by that radical 3. Doing so, we get 1 times the square root of 3, which is root 3, and on the bottom is root 3 times root 3, which just simply gives us 3. So that's it. That's it for this one. I'll see you next time.